Okay. So here we go with the recap. Classes. So remember, classes are templates for making objects. Classes exist. The class definition enforces uniformity of data and actions across all objects of that class, which means if you have a class, all of its objects have the same methods, thus they can do the same sort of things, and they hold the same kind of data, which is obviously desirable in a lot of situations when you want to enforce that kind of uniformity. Okay, so our next step, let's move forward. What is an object? Okay, so again, an object is a particular thing to be represented in Java, what's called one instance of a type. So an instance is like an occurrence or an item, and a type is a kind of thing. So types in Java can be numbers or can be data structures, which are basically objects. So the primitive ones we'll learn early on. Primitives are just simple numeric values, essentially, either numbers or true-false booleans. Other types are class-based. For example, any object you have in Java has to belong to some class. You can't have an object that doesn't belong to a class. And the class to which an object belongs is its type. So for example, you might have a string object, thus its type is string. So remember, any two objects of the same class, by definition, hold the same kind of data, that is the same set of data types, and are able to perform the same actions. They have the same methods. Okay, so with objects, it gets a little interesting. We have this concept called references. So in the Java IDE, every class, every object, every numeric variable has a reference which corresponds to some memory address where its information is stored. Now in Java, that is unseen to the programmer, right? You can't go in and dig around and usefully find where it is. In many other languages, low-level ones like C or C++, you can. So in Java source code, the reference is just the name. And this actually makes it a lot easier for programmers since they don't need to know or manage memory addresses, right? Java does all that for you. So it makes life a lot easier. On the other hand, you give up that ability to control where in memory things are stored, which can sometimes be useful. Anyway, each reference points to exactly one memory address, but references can be changed and multiple references can point to the same address. So let me give you an example. Suppose, okay, I'm going to share now in Paint because some of this is easier to do in Paint. Let's go back and share. There we go. Okay. So suppose in Java, we'll reference that first program I have, right? If you remember that from the other day, we had our customer account class and our server app class. So server app was the main class and customer account held data about individual customers. So suppose in Java, I make this reference, right? I have a customer account CA equals new customer account. And I think with that one, I was supposed to send along a string with a constructor. Yeah, so I'll send along the string Doug, right? Because I'm making an account for me. Okay, so once I do this statement, I'll put the red will be the notes in Java. This statement creates a thing, a customer account object, to be stored at the memory address referenced by CA, okay? We don't need to know where CA actually is because the IDE remembers for us. Okay, so that's the essence there. So somewhere in memory, all the data for this customer account object is stored. And if we want to access it, we just use the reference CA, and the IDE, Eclipse knows that we're talking about this particular customer account object we created. Okay, so what we have, we can draw a big bank of memory here. Okay, so that's our memory. And we'll do a little box somewhere in that. Let's draw a little box. Good. And let's say our CA object exists here. Okay, now how can this have multiple things? Well, this first thing that we've created, right, it points there. As soon as we've created it, it points there. But what else? Well, in Java, you can have another object point to that same thing. So for example, suppose you have a method. You have a method that accepts a customer account object as a parameter, like void, and method is called M, and it accepts a parameter customer account CAX, whatever. Okay, so that's our method definition. Anytime in Java we send along this with a method call, for example, if I call this, if I call that method, right, and I do M and I send along CA, right, the same object that I created later, then this CAX, this local variable that exists only in that method, is likewise going to point to that same location. Okay, so you can have multiple things pointing to the same address in memory. So I'll make a note, CAX as well. They're the same thing. Okay, and this allows you to, this whole idea of referencing, basically, the issue is this. I guess I should be in red. In Java, objects can be very large relative to available memory, which means you don't typically want to make new copies of them if you don't have to. Okay, so reference sharing allows multiple methods to access an object without creating copies. Okay, that's the fundamental issue there. Java, because it's designed for embedded computing devices may often be weak in terms of memory. You don't want to create new objects all the time unless you specifically have to. So in most cases, when you call a method, right, you don't want to create an entirely new copy of the thing you're creating. You want to reference a particular one. So if I'm updating my customer account, like I put in some more credits and my balance goes up, I want to be able to reference that one directly, but from another method. And this is a simple way where Java chooses to do this. Okay, hope that makes sense. All right, I'm going to stop the share for a second. Okay, so we'll proceed onward a little bit, and then we'll talk some more. So that's the idea with references. So anytime we're using this kind of reference that we've created in the IDE, then we can use it throughout the program. Okay. Now, object data. All objects of a class hold the same kind of data. Could be primitives, could be arrays, which are stacks of data of the same type, or it could be other objects, which themselves can contain primitives, arrays, or other objects. So all objects in the class hold the same kind of data, and you have a lot of latitude in the kind of data a given object can hold. All right, so, and of course, two objects in the same class can have different values for the same variable. So for example, suppose you have a class bank account and it has a field called balance. Although every bank account object will have some number for its balance, you obviously would want different bank account objects to be able to hold different account balances because your users would often hold different account balances. Okay. Likewise, all objects of a class have to perform the same actions. They have to be able to perform them. So for a bank account example, things like crediting or debiting your account balance, changing your account owner information, or verifying the user identity, all those things, you'd want any object to be able to do those, but you'd also want them to do it with their own individual data, right? So you want your own object. If you log into a server and you're accessing your bank account, you should only be able to access your bank account. Likewise, if you're changing the owner information on your account, you should only be able to change yours and not some other random users. Okay, so basic syntax for coding. Object methods appear the same as class methods, except they don't have that magic word static. Okay, so if this method in this example here were a class method, if it applied to the entire class, it would have the word static in there, so static void method. But since it isn't, since it doesn't have the word static, we know it applies to only a particular object. So in order to use this method, I first have to create the object, and then I'll have access to that object's method called method. All right, so in Java, method calls are generic and modular. So we've already seen when you have a method in a class definition, there's no reference to a particular object. Okay, so I'm gonna back out into Eclipse for a moment. We'll stop that share, we'll make a new one. We'll go into Eclipse here. Okay, if I'm looking at this customer account class and I have this method set username, there's nothing here that specifies the particular object that this is going to be used for. The reason is it's going to apply to any object in the class, absolutely any customer account. So if I have a customer account object, number one, the outside world knows that it has a set username method and that method accepts a string input, a string parameter. Likewise, since every object of customer account has a username field, I can safely generically refer to that field here. So I can say this, whatever object this is, whose set username method I'm running, that's the same object whose username I want to adjust. So if the customer account object is that CA I just had in the previous example, then if I'm calling CA's set username, I'm going to likewise refer to CA's username attribute. Okay. Let's go back to the slides then. We'll take a moment to do some questions in just a second. Okay, so where are we? Yeah, okay, good. So in Java, method calls are generic and modular, like I said. So when we write the methods, we write them so they can be usable by any object of that class. And similarly, method parameters are given as types with a local name instead of a specific object or variable. So in my class definition, I don't say, I'm going to directly do CA's, say, username. I'm going to set up a method, set username, and then if I want to change CA's username, I call that method for the object CA, and that's how I get to it. The reason why this system works, all objects of a class have the same kind of data and use the same methods, right? So when my class definition says any object of customer account is going to have that username field and it's going to have that set username method, I can call it for any object and the code will still work. It'll have some place to go. Okay, so if the method works for any object of a class, it's going to work for every object of that class. Okay, so this seems like a good point to pause it. I'm going to pause the recording. Okay, there we go. Resuming the recording. This is a good point to bring in the concept of scope. So every reference in Java is valid over some range of code depending on where it's declared. For example, a static variable or a static data field is going to be usable within any method of any object of that class, right? Since it's applicable to the entire class, it's applicable throughout the entire class definition. So it has scope throughout the entire class. And a particular object data field is going to be usable within any method of that particular object. So if I create some data field for an object, then anywhere I'm referencing an object of that type, I'll be able to access that particular data field. And a reference declared within a method would only be usable within that method. So for example, if I declare a temporary variable within a method, or if I'm using a parameter, it's only going to be applicable to that method. If you try to use a reference outside of its scope, the IDE displays an error. Okay, so I'll give you an example right now in Eclipse. We'll bounce over there. Okay, so I'm going to do an example. We'll call it scope because we're very creative. Okay, so this is our scope class, and we're going to have a few things, right? So let's make a static variable to start. So static int x. Okay, so since x is static, the reference has scope throughout the class, right? So for example, I could make a new method here. I could do void m1, and I could say x++. And even though I get the warning in the side, I didn't even get the warning in the side, okay? It still knows what it is, okay? Because it has scope there. Scope exists. X exists throughout the entire class. If I make another method, void m2, same thing, and I want to decrement x. Okay, so I'll put a note here, add 1 to x, and here I'll say deduct 1 from x. Okay, so x is static. It belongs to the entire class. It exists in any method I would create in that class. On the other hand, if I make a non-static one, right, I'll just do an int y. Okay, I'll say y is an object field, and has scope in any object method. Okay, so for example, if I create a static method here, which applies to the entire class, so static m0, okay, static void m0, I can reference x equals 0, and that's fine because x is static. It has scope throughout the entire class, but y equals 0 is going to create an error, right? I have an error in the margin. Reason is it gives the message, if I hover over it, says, cannot make a static reference to the non-static field y. What does that mean? Well, basically, I'm going to put in this. I have to put in a comment. Y equals 0 is invalid because scope doesn't know which objects y you mean. Okay, so y is an object variable. It's fine for within any object method. Like m1, I can do this. Okay, that's fine. I know whichever object's m1 method is being executed, that's the y that we're talking about. Same thing down here. I can deduct 1 from y. There's no problem again because this is an object method. I'll say this is fine because y belongs to a particular object, and so does m1. Okay, that is, whenever m1 is executed, it's for a particular object. Okay, last one, we'll do one more scope thing. So I'll do a thing m3. Suppose I have a method m3 that accepts a string of text. Okay, text is local to this method and doesn't exist outside it. Okay, so if over here in M2, for example, I try to do text plus equals something like that, that's going to be invalid. The reason is the IDE doesn't know what text is, right? So it says text cannot be resolved to a variable, right? That means this is invalid because text only exists in M3. Okay, so that's what scope means. So if you have a static variable, it's good throughout the entire class. If you have an object variable, it's valid for any object methods within that class. And if you have a purely local variable, like a parameter for a method, it only exists for that method. Okay. Is that why object methods don't have the word static? Well, sort of, right? The reason why objects, I mean, that's how you make the distinction. Okay, so object methods belong to particular objects, even though every object of the class will have it. Okay, when you're running it, it's being run for a particular method. Okay, likewise for data, object data belongs to individual objects. And again, even though every object of the class will have the same kind of data. So yeah, it wouldn't make sense to have, in our example that I did in the IDE a second ago, it wouldn't make sense to use an object reference within the static method because the static method applies to the entire class. And I haven't specified which object I'm talking about there. Okay, there's ways to do it. For example, let's bounce back to our Eclipse. For example, the server app class, right? If I look through here, this main method is static. It applies to the entire class. So if I want to reference a particular object, right, I could say customer account C1, and then from within that method, I could say C1 dot whatever. So I can still reference individual objects. I just have to be clear about which ones I do. Likewise, same thing here for savings account. In savings account, I had to make a new savings account object, right? So main is a static method. It applies to the entire class. It's not associated with an individual object. If I want to reference an individual object of savings account through that method, I have to specify that one. So here in line 8, I'm saying this particular savings account object, SA1, I'm going to create that, and then in the subsequent statements, I'm going to do stuff with it. Okay. So I hope that helps. All right, we're gonna resume back to the slides then. Okay, so that's the idea of scope. And understanding that will go a long way towards reducing your frustration when you're trying to code. Otherwise, early on, you'll get a lot of things. I made this static thing. Why can't I use it in an object method? Or I made this object thing. Why can't I use it in a static method? Okay. So we're going to do some current slide stuff. All right. So static versus not static, non-static, right? So since a static method isn't associated with a particular object, you have to explicitly use object references. So for example, here in this static method, we have a thing T. We don't know what a thing is, but we know that T is a thing, whatever it is. So if I want to run something for the class thing, I have to specify the particular object. Okay, so assume this method belongs to the thing class. If I'm going to do that, I have to reference that particular object. But within a non-static or an object method, you only need to use the reference for a different object. Okay, so the object method, again, run for the class thing. If I don't have a reference, it assumes I'm using the time attribute here of whatever object's run method is being executed. If I wanted to use a different one, I would have to specify it in here somehow. I would have to create a new object or borrow a reference from an existing state or accept it as a parameter and use that. Something I'd have in some way I would need to specify that an alternate object is being used. Because otherwise, anytime I have an object variable here, because time doesn't have a reference, so it belongs to the same object as run is being run for. Okay. So, more on methods. In a well-designed Java class, methods are usually called in a modular way. What that is it just means that everything that happens in the method that calls it doesn't need to know about that. So for example, system.out.println, right? I know I want to print out some stuff. I'm going to send some information to it. All of that is going to happen, and it's going to print it, and then the execution flow is going to return back to the method that called the print method. The method that called print doesn't need to know what happens on the print side of things. That's what I mean by modularity. So anytime you have one method calling another, as far as you can manage it, you don't want to have the way the say the print method runs depend on what you sent it. You want to have it be able to operate independently. So the basic structure for that, the method accepts parameters, performs some operation, and if necessary, returns a result. So if I call print, the argument I send, right, whatever text I want to be printed, print line accepts that as a parameter. It actually displays it in the console, and then that's it, because print line is void, so it doesn't return a result. So this is a natural way to check whether inputs are valid before actually performing the operation. So, for example, suppose I have a method that accepts a username and a password. Okay, we can talk about that in Paint here for a second in terms of modularity. Okay. So let's talk modularity. Okay. Sorry, gotta adjust a little bit. Suppose I have a login feature that requires a password and user ID. Okay, fairly typical setup. All I want is to send the password and ID and get a thumbs up or down, right? So I would have some method, it would look like this. Boolean, remember Boolean is our true false variable. I would say Boolean, I'll say is valid, and it would accept a string password and another string user ID. Okay, so any method that calls that, all you really want, I'll add this, any method that calls is valid doesn't need to know the details of how is valid actually does the check, right? Whether it's from some local database, whether it's exact text match or some kind of hash function, okay, whatever, what hardware is involved, etc. Any of those details about how the method runs or how it's implemented in the system, you don't want to have to know that. All you want to know is that if I send in a password and an ID and it's a valid combination, the method returns true and I know everything's okay. And if they don't match, then it returns false and I know things are not okay, and you don't get access. Okay, that's what we want here. So here I'm going to do some code unknown to the outside. This is what I mean when I say in terms of modularity, because once you start putting yourself in a position where the way you call the method depends on how the method runs, then you create all kinds of dependencies in your code, and it's very difficult to make changes to it. Then you say, well, if I change this part of the program, then that's going to have cascading effects on other parts of the program, and it's going to be a big mess. It's going to be a huge hassle to try to safely change anything. If the code is modular, okay, hold on, I'm trying to, this thing is, there we go. If the code is modular, I know that I can change the isValid method, for example, or the hardware it uses, and not have any effect on the external system, right? Whatever called is valid. This makes implementing changes vastly easier. Okay, that's the big point, because we're in the age where you don't just build one system and expect it to last for 5 or 10 years. You're like, everything is changing all the time. It's always being tweaked a little bit. And if you have to do a whole lot of detailed checking to find out if something is safe or not, you'll never get anything done. So modular code is a good principle. All right. So I'll talk for a few more minutes, and then I'll allow a few more questions to do some discussion, and we'll see where we end up. Okay. So additional stuff, overloading methods. So Java will allow you to have multiple methods within a class. They can have the same name as long as they accept a different sequence of parameters. That could either be they take a different number of parameters. For example, one takes 2 ints, another takes 3, or the parameter types are in a different sequence. Okay, so you can have multiple methods within a class that have the same name. The point is, anytime you call one of those methods, the execution flow needs to know exactly where it's going to go. So if, for example, I have 2 versions of a method, say one accepts a string and another accepts a numeric variable, if I send it with a number argument, Java's smart enough to know that, oh, you mean the one that accepts a number. And if I send it with a string, it'll send the execution flow to which of the methods has the string parameter. So it can do that. But in ambiguous cases, sometimes there could be a big problem. For example, suppose I send some entirely different data type. I try to do that. I have one that accepts a number, one that accepts a string, and I send some entirely different object like a graphics component, like a JPanel, say, that isn't either one of those. Then Java won't know where to direct that method call, and so the program will fail, right? It won't compile in the first place. All right. So I'll do a little bit about that, and then we can, this is a good break point. We'll come back on Friday and talk about object creation, constructors, and all that. So I'm going to bounce over to Eclipse very briefly, and I'll give you an example of overloading methods. Okay, so I'll do one more. Call it overload. Come on, you. Okay, so here we have this method overload. If I want to, I could have 3 different methods in here. So for example, void M1, it accepts an int, which we'll call X. And, well, I guess that's fine. This one just accepts an int. Second one, M2, it accepts a double, which is a different kind of number. It's a floating point number. And the third one, void M3, accepts a string, so string S. Okay, so if I have another method here, let's make a method at the top. Whoop. We'll call that void start. And I can put method calls to each one of those at the first place. I can call M1 and I send the number 6. Well, 6 is an integer and an int. So, whoop, sorry, I gave them all the same method. I gave them the same thing. So the execution flow goes to M1 int X. Okay, if I call it again with a different one, if I say M1 and I send along 6.0, right? 6.0 is a floating point number and a double. So the execution flow goes to M1 double Y. Okay, likewise, if I do M1 and I send along some text like word, okay, word is a string, execution flow goes to M1 string S. Okay, so as long as the IDE can figure out which of these different methods it could go to, everything's fine. So key takeaways with overloading. Number 1, a class can have multiple methods with the same name as long as they accept a different sequence of parameter types. Okay? This allows the execution flow to figure out where it should go. Okay. If there's ambiguity, okay, then there can be a problem. Okay. If there's ambiguity, then that is multiple methods might be valid, then often you'll get an error and your code won't compile. Okay? But in general, yeah, in Java, you can do this. And a good example of why this is nice is something like printline. With printline, you can send all sorts of different data types. You can send numbers that'll get converted to strings. You can actually send strings. You can send other primitives. In some sense, you can send other objects as well that might convert to a string or reducible to some kind of text output. So anyway, it would be kind of a hassle if you had to have separate methods coded and created for every time you wanted to use a particular data type. It's much easier to have one method name that allows a different range of parameters. Then it's easier for the users, and when I say users, it's easier for the programmers to deal with. Okay. So this is a good point. I'm going to conclude with the lecturing, with the talking.